Imagine you have this kind of chemical off switch for the human brain.
Right.
You press it gently, and you cure insomnia. But if you press it a little harder, you've suddenly got a CIA truth serum.
Yeah, and if you press it too hard, the brain it never wakes up.
Exactly. So welcome to today's deep dive. Pull up a chair, grab a coffee. You're basically the third person in the room with us today as we dig through a huge stack of pharmacology textbooks, medical history articles, and clinical notes.
We've got a lot to get through today.
We really do, because our mission today is to unpack a century-long saga around one specific word. A word you've definitely heard in movies or, true crime documentaries, but maybe don't fully understand.
Yeah.
We are talking about barbiturates.
Right, those heavy-duty older sedatives that just completely dominated the mid-20th century.
Yeah, and today we're going to figure out exactly how they work, why they were in literally everyone's medicine cabinet at one point, and why they've mostly, though not entirely, vanished today.
It's really a fascinating story. It's not just a medical topic.
No, not at all. It's like a saga of chemistry, Hollywood scandals, Cold War espionage, and this recurring marketing trick that honestly still fools us right now.
It definitely does.
But to understand the massive cultural explosion of barbiturates, we really have to go back to their origin, which is surprisingly accidental and surrounded by this wild folklore.
Yeah, the origin story is almost a myth at this point.
Right. So it starts in 1864 with this German chemist, Adolf von Baeyer, who, by the way, later won a Nobel Prize for organic dyes, like indigo.
Right, for the blue dye in jeans.
Exactly. But in 1864, he isolates this completely new compound, barbituric acid. And the lore in these textbooks is just hilarious. They say he and his colleagues named it after a woman named Barbara.
Which is, it's a great story.
Some versions say she was a waitress at a tavern where they went to celebrate. Others claim it was named after Saint Barbara because they synthesized it on her feast day.
Right, but the sources are actually very clear that this is almost certainly just embellished folklore.
It's totally unverified.
Yeah, it's just a fun anecdote that stuck around for 150 years. But the hard historical reality, which is even crazier, is that Bayer's original compound, that 1864 barbituric acid, was completely useless as a drug.
Wait, literally useless?
Literally zero psychoactive effects.
Right.
No sedative properties. It didn't put you to sleep. It basically just sat on a shelf as a chemical curiosity for almost 40 years.
That blows my mind. The foundational chemical of this massive world-changing drug class just did absolutely nothing.
Nothing at all.
But going through the pharmacology notes, the reason why it did nothing is actually super interesting. It all comes down to the blood-brain barrier.
Right, the brain's bouncer.
Exactly. The brain is protected by this tightly packed layer of cells that are highly lipid, meaning fat. And, water and fat don't mix.
They repel each other.
Right. And Bayer's original barbituric acid was highly water-soluble, so it would just bounce right off that fatty barrier. It physically could not get inside the brain to actually do anything.
And that is the crucial missing piece. It wasn't until 1902 and 1903 that two other chemists, Emil Fischer, who was actually another future Nobel laureate, and Joseph von Mering, they finally figured out the secret.
What did they do?
They made these tiny chemical substitutions at a very specific carbon position on the molecule's ring, the C5 position.
Oh.
By attaching alkyl groups to that one specific spot, they made the molecule fat-soluble.
Oh, wow. So suddenly it just slips right past the bouncer.
Exactly.
Okay.
Easily crosses the blood-brain barrier. So they didn't just invent a new drug, they invented the key to actually get it inside the brain. They created diethyl barbituric acid, which was the first compound in this family to actually knock someone out.
And the Bayer Pharmaceutical Company just immediately jumped on this, right?
Oh, instantly. In 1904, they marketed it under the brand name Veronal.
Which, side note, the sources say was named after Verona, Italy, because von Mering thought the city was just, super peaceful.
Yeah, a nice marketing touch.
But it's wild to me that barbiturate isn't even a single drug. It's a whole family, like a biological tree that just grew out of that one tweaked C5 carbon.
Yeah, it's a massive class of derivatives. And to understand why Veronal was such a big deal, you have to look at what doctors were using before it.
It's pretty grim, right?
Extremely grim. If you had severe insomnia or anxiety, your options were basically coral hydrate, which was synthesized way back in 1832 and was literally known as knockout drops.
Yikes.
Yeah, or you had bromide salts. And both of these were effective at putting a patient out, but they were super super crude tools. They had incredibly narrow safety margins, terrible side effects, and chronic toxicity issues. Like bromides could literally build up in your system and cause actual psychosis.
That's terrifying. So Veronal shows up, and it's just this huge relief.
Right. It was immediately marketed as this scientific upgrade. It was clean, controllable. It was the modern future of medicine.
A shiny new tech of 1904. But the thing is, it worked almost too well. And to understand why barbiturates became so notoriously dangerous, we have to zoom way, way in, like down to a microscopic level in the brain to look at the actual mechanism.
Right. We need to talk about the central nervous system's main off switch.
Let's do it.
It's called the GABA A receptor, and it essentially acts as a tiny channel for chloride ions. When a neurotransmitter called GABA binds to this receptor, the channel opens up, chloride flows into the neuron, and that makes the neuron much harder to excite.
Because chloride has a negative charge, right?
Exactly. It carries a negative electrical charge, so flooding the cell with chloride literally calms the brain down. It is the physical braking system of your brain.
Okay, so I was trying to visualize this while I was reading the notes to map out how different drugs actually interact with this system. So imagine the neuron is this crowded, super overheated room.
Okay, I like this.
And that GABA receptor is a door. GABA, the neurotransmitter that our brains just make naturally,
Right.
is a person whose only job is to walk up, open that door, and let the cool air in.
And the cool air is the chloride.
Exactly.
Oh,
So the
there.
room gets too hot, GABA opens the door, cool air rushes in, the room chills out. Now, modern anti-anxiety drugs, like benzodiazepines, so think Valium or Xanax, they interact with this door in a very specific way. A benzo doesn't actually open the door itself.
Right, can't.
It just taps GABA on the shoulder and encourages GABA to open the door more frequently.
Right. In pharmacological terms, benzodiazepines increase the frequency of the channel openings. They make GABA's job much easier, but they rely entirely on GABA being there to do the actual opening.
Right, but barbiturates operate on a completely different level. When a barbiturate enters the system at a normal dose, it doesn't just ask GABA to open the door more often. It walks up,
Yes.
waits for GABA to open the door, and then it jams a wedge under it.
Yes.
It holds the door open longer every single time, so you get this massive, sustained blast of cool air coming in.
Exactly. They are positive allosteric modulators that increase the duration of the channel opening rather than the frequency. But the fatal flaw in this mechanism happens when you take a high dose.
This is the terrifying part.
It really is. At higher concentrations, barbiturates cross this dangerous threshold. They don't even need GABA anymore. They just walk up to the door and kick it open themselves.
They just bypass the bouncer entirely.
They become the door openers. This is called direct receptor agonism. Benzodiazepines cannot do this. Without GABA, benzos are basically useless, which creates a natural physiological ceiling on their effects.
But barbiturates have no ceiling.
None. If you push the dose high enough, they force so many chloride channels open across the entire brain that everything just stops, including the brainstem centers that tell your lungs to breathe.
Which brings us to this crucial concept in the sources.
Okay.
The therapeutic index.
Yes, very
It's
important.
basically a ratio, right? The gap between a dose that gives you the desired effect and a dose that kills you.
Exactly.
And because barbiturates lack that natural ceiling, their therapeutic index is dangerously narrow. It's roughly a ratio of 10. Meaning, if you take just 10 times the normal dose, it's lethal. To put that in perspective for you listening, the therapeutic index for benzodiazepines when taken by themselves is in the hundreds.
10 times the dose might sound like a large margin to some people,
Sure, sounds like a lot of pills.
but you have to realize how easily someone who is deeply confused, heavily sleep-deprived, or someone who has built up a physical tolerance over months might just groggily take an extra handful of pills in the middle of the night.
Just trying to get some sleep.
Exactly. And that narrow index collided catastrophically with 20th century culture.
It really did. But before we get into the culture, that collision is exactly why treating all barbiturates as the same drug is a massive category error. The textbooks are so careful to point out how wrong this is.
Oh, absolutely.
Treating all barbiturates the same is like treating all explosives the same. Like a flashbang grenade goes off in a fraction of a second, whereas a slow-burning coal keeps a furnace warm all night. They're totally different.
The differences in onset and duration are staggering, and they dictate entirely different medical and cultural applications.
So let's look at the flashbang grenade first. We're talking about an ultra-short-acting barbiturate called thiopental or pentothal.
Right.
This stuff acts in seconds. It became the gold standard for rapid intravenous anesthesia in the 1930s. but its destiny shifted dramatically during the Cold War.
Oh, the espionage stuff.
Yeah. The CIA and other intelligence agencies co-opted it for interrogation programs, branding it as a literal truth serum.
Which is fascinating because the pharmacological rationale behind that theory was that thiopental in subanesthetic doses, so not enough to knock you out, rapidly depresses the higher cortical centers of the brain first.
Such a complex thought parts.
Right. Those are the areas responsible for logic, reasoning, and deception.
Mm.
So the theory was that if you shut down the complex deception centers, the lower, more primitive parts of the brain would just instinctively babble the truth.
But the sources confirmed this was a completely unscientific theory, right?
Totally unscientific.
It makes people incredibly talkative, sure,
Yeah.
and highly suggestible because it drops their inhibitions violently.
Mm.
But it does not physically force them to tell the truth.
No, people can still lie under the influence of it, or they might just simply agree to whatever the interrogator is suggesting because they're so suggestible.
Right. They just want to please the person asking the question.
Exactly.
So that's the ultra-fast flashbang. If we move away from that, we have the slow-burning coal.
Oh.
And this is phenobarbital, which was branded as luminol back in 1912.
Right. This is a long-acting barbiturate. It lasts a day or more in the system.
And doctors serendipitously discovered that because it suppresses overall neuronal excitability so steadily and powerfully over such a long period, it acts as this phenomenal shield against seizures.
It's an incredibly effective anticonvulsant.
So much so that over a century later, phenobarbital is still on the World Health Organization's list of essential medicines.
Yeah, it costs basically pennies a dose.
Which means in resource-limited settings worldwide, and particularly in neonatal units for newborns suffering from seizures, it is a literal lifesaver today.
Decades of safety data in that specific infant population make it virtually irreplaceable right now.
It's amazing. But, so we have the ultra-fast truth serum and the slow, steady seizure shield. The true cultural tragedy, though, unfolds with the intermediate-acting barbiturates.
The unpredictable campfires.
Right, the dolls era. We're talking of drugs like pentobarbital, which was sold as Nembutal, and secobarbital.
Yes, they were the ones that took over society.
In the 1950s and 60s, these were casually handed out to millions of people. Overwhelmingly women, by the way, for everything from mild anxiety and insomnia to weight control.
It was incredibly normalized.
Jacqueline Susan's famous novel, Valley of the Dolls, painted this incredibly vivid picture of this landscape. The dolls were the barbiturate pills. Society was essentially running on a diet of uppers during the day to stay thin and energized, and then downers at night to finally force the brain to sleep.
And often washing them down with alcohol.
Right. And the results were just devastating because of that narrow therapeutic index and the direct receptor agonism we discussed earlier. It was so easy to overdose.
Especially with alcohol. Because alcohol also targets that exact same GABA receptor complex. So you get this synergistic compounding effect that suppresses the respiratory drive even faster than the pills alone.
Which is the exact pharmacological trap that caught Marilyn Monroe in 1962.
Yeah.
The coroner found pentobarbital and chloral hydrate in her system, and then Judy Garland died in a very similar way a few years later in 1969.
And it wasn't just Hollywood icons, it was this massive wave of accidental and intentional deaths across the country that just fundamentally shocked society.
The pharmaceutical industry was staring down a massive PR nightmare.
And a rapidly accumulating body count.
Right. They couldn't ignore it anymore. They had to invent a chemical escape route.
And enter the benzodiazepines.
Here we go.
So in 1955, a chemist named Leo Sternbach at Hoffmann-La Roche synthesized chlordiazepoxide, which went to market in 1960 as Librium. And then just a few years later, in 1963, came diazepam.
Valium.
Right, Valium, which became an absolute global phenomenon. It rapidly became the best-selling drug in the United States.
And their entire marketing pitch was built precisely on that door mechanism we talked about.
Exactly. Roche marketed them explicitly on the promise of safety. They pointed out the wider therapeutic index. They highlighted that benzodiazepines had a genuine ceiling effect on respiratory depression.
Because they couldn't force the GABA door open on their own.
Right. They heavily promoted this narrative that this new class of drugs was fundamentally immune to the fatal flaws of the barbiturates. And it worked. Over the next 20 years, benzos almost entirely wiped barbiturates out of the mainstream prescription market for anxiety and sleep.
But, looking at this timeline, the Roche marketing pitch feels a little too perfect. Like, we just swapped a barbiturate crisis for a benzo crisis. Did we actually solve the problem of a society reliant on chemical sedatives? Or did we just rebrand it?
The consensus in the medical history sources is pretty clear that we simply changed the shape of the problem.
Right.
Benzodiazepines were undeniably much less likely to kill a patient in a sudden, acute overdose. But the profound dependence, the tolerance, and the severe withdrawal issues, those were absolutely still there.
They just kicked the can down the road.
Yeah, and this led directly to the massive benzo crisis of the 1980s, where the medical establishment woke up and realized millions of people were deeply physically dependent on these supposedly safe new drugs.
It's the cyclical nature of pharmaceutical marketing. The pattern in these clinical notes is staggering when you lay it all out.
It really is.
We went from toxic bromides to barbiturates, which were billed as more scientific. Then barbiturates proved lethal, so we moved to benzos, which were safer. Then benzos caused massive dependence, so in the 90s we got the Z drugs, like Ambien, with the exact same promise. No, really, this time it's safe.
It's a striking historical loop. And this actually highlights a really important medical reality that the sources clarify regarding withdrawal, because there is a common misconception that all drug withdrawal is just terribly uncomfortable.
Like sweating out a bad flu for a few days.
Right, but barbiturate withdrawal is fundamentally different and significantly more dangerous.
Why is that?
Well, if we extend our door analogy, the drug has been wedging those GABA doors open for months or years. The brain recognizes that the room is constantly freezing cold, so it adapts.
Right.
It stops producing its own natural door openers. It downregulates its own natural GABA production and physically decreases the number of receptors.
So the brain's natural calming systems just atrophy.
Yes. So if a person suddenly stops taking the barbiturate, they let go of the brakes completely. But because the brain has forgotten how to open the doors itself, they all slam shut.
Wow. And the nervous system is just immediately flooded with unchecked electrical activity.
Yeah.
The brain just redlines.
Exactly. It causes a massive rebound hyperexcitability. This can lead to severe delirium, continuous seizures, and cardiovascular collapse.
That's terrifying.
It is. Barbiturate withdrawal is inherently life-threatening. A patient cannot just sweat it out at home. It requires highly supervised, gradual medical tapering.
So in terms of acute physical danger during withdrawal, where does it rank?
It sits right at the top alongside severe alcohol withdrawal. They're far more immediately dangerous to withdraw from than opioids, for example.
That is wild. Given how dangerous they are, and considering benzos and Z drugs took over the anxiety and sleep markets decades ago, you might assume barbiturates are completely extinct.
You'd think so.
But aside from the phenobarbital used for neonatal seizures, they do still exist, just in very specific, heavily guarded niches. Like in the U.S., a barbiturate called butalbital is still prescribed as a component in certain headache medications like Fioricet for severe migraines.
Right. Though their most profound modern legacy, where they really cast the longest shadow today, is at the end of life.
Right.
Because they are so relentlessly effective at painlessly stopping the central nervous system in high doses, pentobarbital is now the standard agent used in veterinary euthanasia.
That makes sense.
It is also the primary drug used in human physician-assisted dying protocols in jurisdictions where that is legal, such as with the organization Dignitas in Switzerland.
And reading through the legal and clinical notes, this exact same mechanism of action has made barbiturates the center of an incredibly complex, ongoing global supply chain disruption, specifically regarding capital punishment in the United States.
Yeah, the sources outline a very specific sequence of events here that we should unpack.
Let's do it.
Thiopental, the ultra-short-acting flashbang we mentioned earlier, was originally part of the standard lethal injection protocol in the U.S. However, the sole manufacturers of the drug in the United States and the European Union eventually halted its production and distribution entirely.
Right, so the pharmaceutical companies executed a manufacturer-driven disruption specifically to prevent the drug from being used in American executions.
Exactly. And because state penitentiaries suddenly couldn't acquire thiopental, they were forced to scramble and rewrite their execution protocols.
To find a replacement.
Right. Many states attempted to switch to pentobarbital, which immediately led to further manufacturer boycotts and severe supply shortages of that drug as well.
And the immediate ripple effect of this was that states were forced to improvise with other, entirely untested combinations of newer drugs.
Which sparked a massive wave of ongoing legal litigation.
Right, about the efficacy and legality of those new protocols. It is a really stark example of how a disruption in the supply chain of a single century-old chemical can ripple out into the highest courts in the country.
It perfectly illustrates how intertwined pharmacology is with law, ethics, and global commerce. I mean, the chemical structure of the drug itself hasn't changed a bit since 1904, but the context surrounding it is constantly shifting.
It really is. Looking at this stack of history and chemistry, it's just mind-blowing that a tiny chemical distinction, literally just attaching fat-soluble molecules to the C5 carbon in 1903, unlocked a century of medical miracles, like stopping seizures in newborns while also fueling these devastating cultural tragedies.
Yeah.
It proves that how a drug works at the microscopic level, the exact mechanism of wedging that GABA door open, ultimately dictates its entire historical destiny.
Absolutely. And if there's one practical lesson for you listening to take away from this history, it's just a healthy dose of historical perspective.
Be skeptical.
Exactly. The next time you hear a pharmaceutical advertisement promising a perfectly safe, consequence-free new miracle cure for sleep or anxiety or stress, remember the barbiturates.
Remember the benzodiazepines?
The human brain is a finely tuned, highly adaptive system that simply does not like its brakes being forcefully overridden.
Which leaves a final, slightly provocative thought for you to mull over. If the exact same marketing script, our new sedative is safer than the last one, trust us, worked flawlessly for chloral hydrate in the 1800s, barbiturates in the 1900s, benzos in the 70s, and Z-drugs in the 90s. What is the supposedly perfectly safe medication that we all take today, right now, that the deep dives of the year 2100 will look back on with absolute horror?
That's a scary thought.
Because as we've learned today, sometimes we think we're flipping a clean, safe light switch, when really we're just jamming the door open and hoping the room doesn't catch fire.
Okay.
Thanks for joining us on this deep dive into the sources. Catch you next time.